September 12, 2025. A date that will likely be remembered in astronomy for generations. On that day, telescopes across the world caught sight of something that should not exist. A massive object cutting through the black gulf of space blazed into our system with a brilliance that stopped astronomers in their tracks. Its tail stretched across the heavens 5 times the width of a full moon, dwarfing every cometary visitor since Oumuamua. The astonishment hadn't even faded when, within hours, a second intruder was confirmed. Another celestial body on an intersecting path, racing toward the sun from the opposite side of the sky. 2 new arrivals, weeks apart but on converging courses. The odds of this happening by natural chance, experts whispered, were almost non-existent. The official word was simple: twin comets. But many inside the field weren't convinced. Too many numbers didn't add up. Too many signs pointed to something else, something deliberate. As the hours turned to days, whispers spread that one of these objects wasn't a comet at all, but a colossal engineered craft. Was this an accident of nature, or the first step in a mission triggered not by cosmic randomness but by something connected to us? That question began with the SH spacecraft's Swan instrument. On September 12th, its solar wind camera flagged a blinding source in the data feed, brighter and larger than anything it had recorded before. Analysts froze. This wasn't just a statistical blip or a sensor ghost, it was real, sharp, unmistakable. An enormous luminous object was burning across the system. By nightfall, the first measurements came in. Its tail wasn't just impressive, it was unprecedented, stretching nearly 2.5 degrees across the sky, 5 times wider than the moon seen from Earth. Initial magnitude readings put it at 7.4, already glowing strongly enough to be glimpsed through backyard telescopes and even decent binoculars. Almost immediately, the news leaked into amateur astronomy channels. The scramble was on. Across the world, stargazers set up their scopes, hoping to catch proof of what the satellites had just unveiled. Within 2 days, the first striking ground-based image emerged out of Australia, a streak so immense it spilled against the frame of the observer's camera. On September 13th, the International Astronomical Union made it official. The visitor had a name: C2025R2, Swan, labeled in honor of the instrument that first saw it. And just like that, a frenzy began. Both professionals and amateurs locked onto the object, swapping raw measurements and eerie photographs across hemispheres. Normally, new comets require giant observatories and sensitive sensors to spot it all, faint smudges against black infinity. Swan, however, blazed so boldly that almost anyone could see it if they knew where to point. Its growing tail cut through Virgo like a celestial sword, brightening by the day as it fell inward toward the sun. Excitement spread quickly, but alongside it came disbelief. This wasn't a routine frozen traveler from the Oort cloud. The math rebelled against expectation. Swan was immense, luminous, and unnervingly fast. By the end of its first week in official recognition, many agreed. The inner solar system had not witnessed an object like this since Hale-Bopp, or perhaps much, much longer. And as its radiance climbed, the question deepened, not what Swan was, but why it had chosen now to appear. But Swan was not alone. C2025R2, soon known everywhere as Swan, wasn't the only visitor. Just days before its discovery, astronomers had already logged another anomaly: 3I Atlas, an inbound traveler cutting across the sky from an entirely different sector. Swan's trajectory traced backward through Aquarius. Atlas approached from Sagittarius. On a star map, their entry points were separated by more than a quarter of the entire sky, yet both were now racing inward, fated to pass the sun within the same narrow 10-day window. For Swan, that critical point, its perihelion, would arrive around October 20th. At a distance of about 150 million kilometers, Atlas would skim past only 3 days earlier on October 17th, at roughly 203 million kilometers. In astronomical terms, their perihelion points were practically neighbors, just 50 million kilometers apart. To put it in perspective, Mars, at its closest, never comes within that range of Earth. That overlap wasn't the only anomaly. Their orbital planes, too, defied chance. Swan's path was tilted steeply, over 60 degrees above the planetary disk. Atlas, by contrast, plunged in almost perpendicular, slicing through the solar system's architecture as if it belonged to no family of comets at all. These were not the meandering long-period wanderers astronomers were used to. They were intruders crossing from wildly different angles, yet converging on the same stretch of time and space. The timing was almost mocking. From October 8th to 18th, ground-based observers are blinded by the sun's glare. Telescopes can't safely point into that radiant zone. For astronomers, those blackout days are routine, but in this case, they lined up with precision. Swan and Atlas would make their closest passes during the exact period when Earth's eyes could not follow. That meant their moment of closest approach, not only to the sun but to each other, would unfold just out of reach, a perfect curtain drawn across the most crucial act. The odds of this happening naturally? Vanishingly small. Experts in orbital dynamics struggled to put a number to it, but their language was clear. Coincidence seemed absurd. To those following closely, the convergence wasn't simply striking, it looked orchestrated. Atlas itself didn't behave like any comet on record. While Swan's brilliance stole headlines, Atlas unnerved the labs. Its first surprise came from spectral scans. Instead of the familiar blend of iron and nickel vaporizing in sunlight, Atlas appeared almost pure nickel, with almost no iron at all. The claim sent shockwaves. Comets, without exception, show iron signatures. For Atlas, the anomaly was so dramatic that some laboratories initially refused to publish. Surely, they argued, the instruments were miscalibrated, but as more observatories chimed in, the pattern held. Something about Atlas was chemically wrong. Then came its emissions. Typical comets exhale water vapor in great clouds as they heat. Atlas, however, seemed to breathe carbon dioxide at levels 5 times higher than its water output. That was rare, but not impossible. What shook researchers was what happened next. Observers began logging pulses. 3 of them. Sudden bursts of acceleration in its flight, each one lasting days, each one coinciding with abrupt changes in the color of its tail. On July 29th came the first pulse. A brightness spike, spectral tone sliding from reddish to neutral. 2 weeks later, August 14th, it happened again. The third arrived in late August. Each time, Atlas seemed to jolt forward as if something inside had fired. Natural comets don't leap in jerks. They fade and brighten slowly, their outgassing gradual. But Atlas behaved as though it were under command. Some called it thrust, others thrust modulation. Whatever it was, it lined up across independent observatories worldwide. If real, the numbers implied staggering power. 10 gigawatts, enough to rival 10 nuclear plants, delivered from a body just tens of kilometers across. Astronomers argued bitterly. Peer reviewers pushed back, accusing observers of miscalibration or statistical bias. But the reports kept coming. Too many eyes were seeing the same thing. Too many instruments in too many places picked up the same jolts. The more data came in, the less Atlas resembled a comet. To skeptics, it was still a strange but natural outlier. To others, it looked like something else, a machine, running on a schedule of burns and course corrections. If so, then the synchronized dance of Atlas and Swan wasn't a cosmic accident. It was a maneuver. If Atlas rattled astronomers with its erratic pulses, Swan simply defied imagination. Its sheer size and power pushed it into a category of its own. The numbers painted a picture almost too vast to accept. A tail stretching more than 2.5 degrees across the sky, brightness rivaling the legendary Hale-Bopp, and a nucleus radiating energy estimates in the tens of thousands of gigawatts. Some figures placed its output at more than 10,000 gigawatts, exceeding the electrical capacity of the entire human civilization. That wasn't what unsettled the community most. It was the way Swan seemed built to endure. Unlike comets that crumble under solar stress, Swan remained steady, even as it plunged deeper into the furnace of sunlight. Its light curve should have fluctuated wildly. Instead, it maintained a stubborn stability, refusing to fade or fracture. Soon the whispers began. Spectral analysis hinted at something unusual. The nucleus reflected sunlight with an edge, a sharpness inconsistent with dusty ice. Amateur spectroscopists suggested a nickel-cobalt blend, a combination valued on Earth for resilience and strength. It wasn't long before forums and podcasts latched onto a phrase, nickel-cobalt hull. Then came the halo. Observers across continents began reporting a shimmering sheath around Swan's core, not static, but shifting patterns of silver light. Some dismissed it as an imaging artifact, but as more reports arrived, a new hypothesis emerged. That Swan carried a plasma envelope, a kind of electromagnetic shield. Such a barrier could explain its uncanny survival, protecting it from solar wind and cosmic debris alike. The name caught quickly: the fortress. The behavior of its tail only deepened suspicion. Instead of streaming randomly under solar heating, the plume showed tiny rhythmic pulses. Photometry revealed micro-adjustments, minute changes in brightness and orientation like controlled bursts of thrust. The pattern repeated with unnerving regularity as though the object was steering itself. And then its orbit. Swan's path wasn't just long, it was prehistoric. Calculations revealed a return period of 22,554 years. The last time this body had passed near Earth was during the Ice Age, when glaciers ruled the continents and human civilization barely existed. That raised a staggering implication. If Swan were truly engineered, then it had been traveling on a set course since before recorded history. And yet, after tens of millennia, here it was, arriving in perfect synchrony with Atlas. Coincidence? For many, that word was wearing thin. The comparison became unavoidable. Atlas looked agile, responsive, like a drone making corrections with bursts of thrust. Swan looked like a juggernaut, armored, shielded, unstoppable. If Atlas was a scout, Swan was a tank. The contrast seemed deliberate. Two entities built for different roles yet arriving together. The theories multiplied. Some suggested Swan was an ancient probe, programmed millennia ago to awaken at this moment. Others imagined it as a fortress in the literal sense, a vessel hardened against space for reasons unknown. The thought that such a craft might be maneuvering inside our solar system pushed the debate far beyond science. Governments began issuing careful denials. Space agencies urged caution, but privately the files grew thicker. The timing was too perfect to ignore. Two massive objects converging during a solar blackout, one flickering with signs of thrusters, the other cloaked in a shield-like envelope. No one could say what mission they were on, but almost everyone agreed. It looked like a mission. Some speculated it was a rendezvous. Both objects drawing energy from the sun, topping up reserves, handing off data, or repairing systems long dormant. Others painted darker scenarios, an intervention, a pursuit, or even rival factions arriving for conflict. Whatever the truth, the conclusion was unavoidable. Swan was no ordinary comet, and with Atlas beside it, the solar system was no longer just our home, it was a stage. The mystery of Swan and Atlas wasn't confined to telescopes. It spilled backward into time. Some researchers began digging into cycles. A return period of 22,554 years meant Swan had last swept through during the Ice Age, when glaciers dominated and human culture was only beginning to rise. In Greenland and Antarctica, ice cores tell the story of those years. Layers of dust and chemical traces marking sudden upheavals in the sky. Some theorists dared to connect those signals with visits like Swan's, suggesting that ancient eyes may have once witnessed the same blaze across the heavens. One site in particular entered the debate, Göbekli Tepe in southeastern Turkey. Built more than 11,000 years ago, its carved pillars bear animals, symbols, and star-like patterns. A handful of scholars have argued that those markings record celestial events, cycles of comets, maybe even the return of something like Swan. Mainstream archaeology resists the claim, warning against speculation, yet the timing lingers. If Swan had last appeared during humanity's fragile dawn, might its memory have echoed through myth and stone? Whether coincidence or coded warning, the suggestion adds a mythic weight to what is already the strangest astronomical event of the century. But as the cultural arguments spread, a more immediate problem emerged: silence. From October 8th to 18th, during the solar conjunction blackout, official observatories went dark. That was expected. But what followed was not. Internal directives leaked from agencies in the US and Europe ordered extended suspensions of radar tracking and high-resolution imaging. Requests for alternative coverage were denied without explanation. Data that normally flowed freely was rerouted or delayed. The effect was total. At the precise moment when Swan and Atlas crossed closest to the sun and to each other, the public record went blank. For official channels, it was as if the two most extraordinary objects in decades had vanished. But the amateurs did not stay quiet. Bill Gray, a veteran orbital tracker, sent out a call. Keep your scopes on the sky. Log everything. Share before it disappears. Across forums, encrypted chats, and small observatories, a patchwork network lit up. The Ibero Collective in Spain and Portugal pooled sensor data. In the US, backyard astronomers linked wide-field arrays, scraping every possible photon from the glare. Some groups even hijacked unused weather satellites and amateur radio telescopes, desperate to keep a line of sight. The blackout wasn't just an obstacle, it became a rallying point. The grassroots effort grew into a decentralized resistance to silence. Where governments and agencies turned off their feeds, hobbyists and independents filled the vacuum, patching together light curves, timing flickers, and comparing notes in real time. For weeks, the only trustworthy signals came not from billion-dollar observatories, but from backyards, rooftops, and improvised labs. And so the story closes not with answers, but with questions. Two anomalous objects, one steady as a fortress, the other twitching with strange bursts, entered the inner solar system together from opposite corners of the sky, converging at the same time in the same narrow corridor, during the same blackout window. The statistics defy chance, the evidence defies easy explanation, and the silence of official channels only deepens suspicion. Whether Swan and Atlas are ancient probes returning on a long-forgotten cycle, rival constructs rendezvousing at the sun, or simply the most extraordinary natural visitors in millennia, one fact remains clear. The human story is no longer written only on Earth. From now on, anyone who looks up at the sky must wonder, what else is watching with us?